Greetings, everyone. I'm Stefano Panelli from Alessandria, from the Conservatorio of Alessandria. I have a bachelor's degree in electronic music, and I'm soon to be like master's degree in electronic music. Today, I will showcase to you my own technique of making generative soundscapes without using AI. So basically, I know it sounds like funny today, being like having this much of artificial intelligence, but the thing is, I choose this way because it is basically my journey from Super Collider to Max MSP, and so that's how I learned how to make generative stuff without using any like high-tech solutions. And so I will start with a little demo. Mind that it will be in mono, but this method can work on like multi-channel or also stereo. So. So basically, what you heard was like all synthesis and all totally generative stuff. Nothing is prepared before. What I'm showcasing today is my own techniques to produce something like this, to engineer the actual patch. And those techniques can work in every audio and audio processing and synthesis environment, also hardware. Basically, I've set up 3 sound generators that everyone has a stereo output. Let's start with the first one. First audio generator is like a hybrid sampling ring mode generator. I will go quickly through it. There is 128 oscillators, like sine wave oscillators, that are being multiplied by one another, like first by the second, by the third, etc. And these having like some beating frequencies in the oscillators makes a really kind of rhythmic and kind of randomic signal. And I sample these in real time and use the sample to produce various parts of my generator. For example, the bass is from the sampling, the ambience is from the sampling, etc., etc. Second generator is based around wave shaping and filtering. If you need, I can open. It's like some kind of freestyle stuff with Gen. Basically, I discriminate between upward going cycle of the wave and downward going cycle of the wave. I took inspiration by clip synthesis by Maurizio Giri. There's synthesis techniques that basically divides the audio in positive spikes and negative spikes, and you can run different parts of the signal in higher than 0 and lower than 0. And then it goes through resonance filters. The third part, that is the most complicated one, is basically also ring modulation synthesis, but with resonant bandpass filters to amplify basically the clicks that ring modulation synthesis produces. Uh, the like special thing about this method is like basically in the control layer. I selected some parameters in the sound generators blocks, not to be totally randomic, but to have like some macro functionalities, so I can basically manage multiple parameters in one go. And then I use this technique that is basically this kind of stuff. I have a random generator, a low-frequency random generator that maybe in hardware you can low-pass white noise, basically. In Max MSP you have a handy function that does this. And then I use basically a comparator to generate banks and to update another type of values. This system makes me basically control the speed of my ambience, as written here, coarse speed randomization. And also I can use if I choose the right parameters, I can link those parameters like with updates also in some other environments. For example, imagine if you are building an audio system, for example, for a video game, not in MSP, or for example in a audio installation, you can leave some parameters to basically other stuff that can run in the installation, for example, people triggering sensors and stuff. And also, I have the same principle applied to the output of my generators. My approach to this is based around dividing my patch in blocks. I have a control layer, I have a sound generator, and post-processing. It's like a way of thinking before and during the designing phase to have most of the decided before. So you have a really nice control of your signals. And then you go into the post-processing part, that is basically the managing of the audio output. And every couple of signals that outputs from the generators are sent to a VCA block that is controlled also by the randomic signals, just to basically make the volume change for the separate channels. Basically, it's like I'm running the mixer of it. And also, another type of block that I usually, or layer that I usually use is, I call it an analysis block. Basically what it is for example, I choose a parameter of the audio I'm outputting. In this time is amplitude, and I run it to a comparator. And I manage the output to the effects block. Effects block right now is a reverb that is managed with this kind of analysis type. And also I randomize the value for each reverb, the room size for each reverb. Other stuff I could look. I took out the control layer and out layer speed just to show you how they interact with the patch. So basically, the higher the value, the faster the events are gonna happen. So if I run, you will see that each parameters basically have a different speed based on these values here. The higher this value, the higher the speed, and the higher the change of the events. Right now, because as I said, it's stereo and it's not mixed mono, so this. And basically, that's all in my technique. Something else you can implement is, for example, feedback. You can implement some cybernetic stuff. For example, the managing of the feedback amplitude through amplitude, basically monitoring. You can look at frequency output with a frequency, how it's called, the frequency detector. Like the technology that is used in tuners, for example. If I output 100 hertz, something happens. If I output 200 hertz, something else happens. So this type of conditional stuff really helps with this kind of functions. The thing is, every time I will open and close a patch, the output of the patch really changes. And also is like a way to generate samples that never repeats. Higher dynamic range than usual. For example, other goals for this type of project, for example, as I said, is like situational sound design, for example, in programs like UIs, or I can imagine it working on cars, for example. You can have a generative type of sound engine that works on the sounds in the car. Right now we have like a sound for electric cars. You have I don't know how it's really called. You have a sound that makes people hear you, because the electric car doesn't make actual noise. And you can use these type of methods like parameters managing to make this kind of sound, to make it more natural, because right now they use sampling most of the time. Or for example, as I said, you can use it in art installations, and link the parameters to whatever you like. And so basically the possibilities are endless in this kind of method. Thing is more like a way of thinking when you are designing than actually like really new techniques. And so that's all. If you have questions, feel free to ask. And thank you for the organization to choosing me for this presentation.
Thank you so much. Lots of questions for Stefano. We will start with you because you're going to have to set up soon.
Did you implement at any point seeding for the random objects? Sorry? Did you implement at any point seeding for the random objects?
The way I implement seeding is not like using actual seeds. But if I want some parameters to be linked or like relative to each other, I usually make some permutation to the randomic signal instead, because I prefer it to give more than a seed. I usually had to work with seeds more through AI than this kind of stuff. You? Oh, okay.
Right here. First of all, this is great. The user interface, the being able to deepening to any of the boxes. Mm-hmm. This is a wonderful UI pattern. We see this over and over in generative solutions. Have you ever played with Grasshopper as a plugin for Rhino?
No.
Have you ever played with Bitwig and its grid?
Bitwig,
modular synthesizer?
Yes,
right, they both have the same notion, just as you showed. Like I can have widgets on the screen, wire them up, and then go deeper, and then go deeper, and then go deeper. That really has a lot of power, and seeing that play out, and this is really something. That's why I was wondering how much inspiration you pulled from those other existing sort of UI methodologies of this sort of abstract box towering.
Okay, actually, my inspiration for this comes from basically having to do with hardware, because the way I usually make patches with hardware is like having this way of thinking. So I think about some parameters being used in a synthesis of like sound generator, and then I implement. So how can I move these controls? How can I move this set of controls without using my hands? Because basically what I do, like in a like creative environment, I like to watch the machine more than like putting my hand in it. Because sometimes the machine can have a, I know it's weird to say, but it can have really nice, almost real lifelike characteristics. Also in analog, feedback is not implemented like in digital. It's being.
All the time we have for questions. I'm sorry. We'll have to take the rest offline.
Okay, sure.
But Stefano will also be performing this evening in our performance evening.
To go to the sound.
So you'll have an opportunity to hear a little bit more. For now, let's thank the speaker again and go to our last talk.
Thank you.